Welcome to lecture 8 of the course CS213 Object-Oriented Programming of the Guwahati University of Science and Technology. We will continue our discussion of classes and objects. We are having a deeper look at the classes and objects, and the concept that we will be discussing today is composition. So the sole agenda for this lecture is composition with the help of an example. Composition is one of the important concepts in object-oriented programming, and it helps us in reusing our code, and we'll be looking at it with the help of a couple of examples. The reference book again for this course is Java How to Program Early Objects version of the Detail and Detail series. And as we understand that the main concepts of the classes and objects have been discussed in chapter 3, but you can find this specific topic in chapter 8 of the book in section 8.8. And you can also find the relevant Java tutorial if you are interested in getting to know more details about these topics. So we will look at a date class first, and we are given an example in chapter 8 of the book. The date class has three integer variables that are the instance variables of the class, that is the day, a month, and an year, that represent a date. And as we can see that the three instance variables are declared as private, and we also understand that these instance variables need to be within a specific range and to be able to get a valid value for these instance variables. So we understand that the month needs to be between 1 and 12, a date cannot be bigger than 31 and cannot be less than 1, and a year has its own specific range or format. The constructors use three int parameters, as we can see over here, and we will need to validate these values within the constructor. It also validates a day if it is out of range or invalid. You can find the complete code of this example in the book. We'll also look at this when we do the coding for this example. But here in the slide, a brief section of the code is provided to highlight the main points of the code. So we understand that the different months in the year have different number of days. So a January has 31 days, a February usually has 28 days, and it can sometimes have 29 days. And similarly, March again has 31 days. We have 30 days in April and 31 days in May, and so on and so forth. And we want our counting to start from 1. That is why this 0 index is initialized to 0, and you can see that there are 13 elements in this array, and each element in each index position shows us the month that we have the maximum number of days at that index position for each month. And we will see how we can validate the maximum number of days in a month against these indices. We also can see that the array is declared as static and final. Final is the same as constant in Java. If you have studied constant variables in C++, you would understand what a constant variable is. That is, we cannot change the value what it has been initialized, so we do not want anybody to change the maximum number of days in our months. That is why we have declared it as final, and we have also declared it as static so that all the objects of the date class should have access to the same days per month array. So the days per month array shows us the maximum number of days at each position or in each month, and the month is shown by the index position of each element in the array. The constructor then will initialize each these instance variables to the variables or to the arguments that it has received. After it has double checked that the value is valid, we will look at the validation code in the example. And then we use the toString method that will return the date in a string format. So we want the date to be in a format separated by the slashes. So we have month, a day, and year separated by a slash. The toString method returns the object's string representation. We have looked at the toString method previously. What it does is it returns us the string representation of the object. Now composition, for example, a class can have references to objects of other classes as members. In other words, we can say that we can use a class as a data type in another class, and this is called composition and is sometimes referred to as has a relationship. So for example, we can say that we have an employee and the employee has a birth date, or the employee has a hire date. Now we have a separate class for the date, a class for the date, and the date has its own validation and its own variables. Now if we need to put the date in the hire date of the employee or for the birth date of the employee, either we'll need to declare three variables, that is day, month, and year variable for the hire date, and we will need to declare the same number of variables for the birth date as well to show the record of the employee's hire date and birth date, and we'll need to provide the values for these variables each time we create the object for the employee class. Alternatively, what we can do is, once we have created the date class and we have performed all the validations once, we do not need to recreate it each time we create an object for the employee. We can simply use the date class as a data type in the employee class. So for example, the instance variables of the employee class now are the first name, the last name, the birth date, and the hire date. Members' first name and last name are referenced to string objects, as we saw in the employee example in our previous lecture. And members' birth date and hire date are references to date objects. We look at it in the code, but as we can see over here in this graphic, when we create an object of the employee class, what we do is we are passing two string values. For example, we are passing the first name, the last name, and we are passing the objects of the date class to the constructor of the employee class. What we have done over here is we have created the birth date of the employee, the birth object of the date class that represents the birth date of the employee, and we have created a hire object of the date class that represents the hire date of the employee. And then we are passing these two objects as arguments to the constructor of the employee class. And the constructor of the employee class will initialize or assign these arguments or these values to the instance variables, that is the first name, the last name, the birth, and the hire. These values will be assigned to the instance variables of the employee class. And then we can print the object of the employee class. What this printing will do is this will implicitly call the toString method of the employee class. And since we have already applied the format of the object that we want to, the output of the employee class would be there, and we have set that format in the toString method, and that when we print the object of the employee class or any class that has the toString method, it implicitly calls the toString method and prints the object's detail in the format that we have set in the toString method of that class. So the first name and the last name instance variables get references to the string objects, as you can see over here. And the birth date and the hire date get references to the date objects. We have created objects of the date class, and then we are passing these, or we are storing these objects as variables in the employee class. You can see here, this is the object of the employee class, and it has these 4 instance variables. If you look at the output of this line, then it prints the first name, the last name, the hire date, and the birth date, in the way we have set this code in the toString method employee class that we will look at in a little while. So if we look at these classes, as we can see over here, that we have a date class, and the date and employee has a relationship. Many classes will show us a has a relationship, that when we are storing the details for that class or for a variable, then if you realize that we would require more than one variable to represent a single kind of a detail in another class, then what preferably we can do is we create a separate class, and we set all the formats and the detail for that those variables in that separate class, and we can then create an object of that class to represent those details in the other class. For example, if you want to include the details of course in a student class, now a student can have multiple courses. A student can have 5 to 6 courses in a semester, or maybe 4 or 5 or 6, and sometimes more than that. And the course in itself has quite a few details to it. For example, the course will have a course code, a course name, the number of credit hours may be. Now, if you want to store the details of a course for a student, either you would want to create like 3 variables for each course in the student class, and if the student has 6 courses, that means you would need to create 18 variables to represent 6 courses for the students. Alternatively, what you can do is you can create a separate course class, and the course class will have its own variables like the course code, the course name, and the number of credit hours. And then you can add a variable of the course class in the student class to represent the courses that the student is taking in that semester. Similarly, A faculty member can have a relationship with the course class. A faculty may be assigned 2 or 3 courses or maybe more courses, and each course, as we understand, has its own details. So we can create objects of the course class in the faculty class to represent the courses that the faculty is taking. So if you have a situation where we need to create multiple variables for the single kind of information, for storing the single kind of or representing the single kind of information in another class, then we would preferably create a separate class for those variables and then create an object of that class in our class that we want to store in the details in. For example, here we have a date class and we want to store these details like the hire date and the birth date for the employee. Now we can see that the date in itself has 3 variables. If we weren't using composition, what we would need to do is we would be creating 3 variables for the birth date, like birth month, and birth year, and three integer variables for the hire date, like hire day, hire month, hire year, and we would need to validate these variables as well. So we would be performing 2 validations for the same kind of details or for the same kind of variables. But what we alternatively can do is, since we have 3 variables of the date class, we can create a separate date class that can represent a date anywhere that we want it to. For example, we can create a variable of the date class in our employee class. That is the instance variable of the employee class now, and it will bring in all the details of the date class in the format that we have in the toString method of the date class. And now we simply can pass these as arguments to the constructor of the employee class. As we can see over here, we can pass the objects as arguments to the constructor of the employee class. And then these will be assigned to the respective instance variables. And in the test class, as we saw in our previous slides, that we can create the objects and then we can pass the values for those objects to the constructor. So now we will have more than one class or more than 2 classes in our projects, and what should happen is that when we run the test class, when we compile the test class, what would happen is a separate class file will be created for each class in our project. So when we compile a .java file containing more than one class, the compiler produces a separate class file with the .class extension for every compiled class. When one source code, that is the Java file, contains multiple class declarations, the compiler places both class files for those classes in the same directory. For example, in our test class, you would have an object for the date class and we would have object for the employee class. And when we compile this test class, it will create a class file for the employee test class, a class file for the date class, and a class file for the employee class within the same directory that we have stored these classes in, or these Java files in. A source code file can contain only one public class, otherwise a compilation error occurs. We will be creating separate files for each of these classes within the same package, If you do not want to create separate files, what you can do is you can create class date, for example, like in this example, a class employee. If you want to use the same file, and then there can only be one public class in that file. So you can declare the public class employee test as public, because this is the class that contains the main method, and it will start this is the class that will start your program. Then you should declare this as public, and you can then declare other classes in the same within the same file as non-public classes. And when we compile this Java file, you will see that a date.class file and an employee.class file have been created for you within the same directory. Now let's look at this complete code for the date class. We said that we will be validating the instance variable for the date. For example, the month should only be between 1 and 12. A day can only be between the numbers 1 and 31, and then although we are not validating the year in this code, but you can also try and validate that the year is within a specific range. For example, at least we cannot have a negative value for the weight, or a zero value maybe. And as I said, that we have a static final array that will store the maximum number of days for each day, for each month in our calendar. For example, at index position 1, that is the January, we have 31. At index position 2, that is February, we have 28. And index position 3, that is March, we have 31. So each index position shows, so each element shows us the maximum number of days in that month that is shown by the index position of that element. If we look at the constructor of the date class now, for the validation of the month, for example, we want to exclude the 0 from our counting, because we have this 0 for the 0th index position, and we want to exclude it first thing in our validation, so we do not have a 0 month, to make sure that we are starting from position 1 in the array. So we will remove the 0, starting point 0, if the month is less than or equal to 0, or if the month is greater than 12. We have an if statement that if we have this kind of a situation that shows that we have an invalid value, we will throw an exception. Throwing an exception is the same as creating an error when we have an invalid compilation error or something. When we have a compilation error, or we have some invalid value for something, the compile creates an error for us. We can also do exception handling. We will have a brief look at exception handling over here. We will have a complete lecture or exception handling in our future lectures, but here we can say that we can create an error when we are trying to validate our values, and we say that when we get an invalid value from the user, so we can create an error statement, and that can be done by throwing an error. So throw is a keyword, nib is a keyword, and then we have a built-in class that we can create an object for over here, that illegal argument exception. We pass an argument to this constructor, and as we can see that it has been implicitly imported from java.lang class that also has our print statements. And we can pass a parameter to that, and it will be printed if we have an erroneous value for our variable. throw over here is a keyword, nib is a keyword, and we can use these to print an error statement, and if we have an invalid value for our variables. We can also use the print ln statement, but the difference between throwing an error and printing an error is that when we print the error, our execution will go to the next line without doing anything. But when we throw an error using the throw nib illegal argument exception or throw statement, what it will do is it will throw the error and stop the program right at this point. So that is the difference between printing the error and throwing the error, or using exception handling. We'll try to use exception handling instead of just printing the error statement like we have commented out over here. Okay. Similarly, we can validate the day. So we may need to make sure that the day is not equal to or less than 0. We do not have a 0 day in a month. And then if the day is greater than the maximum number of days at any position, a month over here will be shown by the index pole. Now the index positions of the elements will be shown by the month over here, and we would want to check in our array days per month that what is the value at that index position in our array. So for the first array, if we have, for example, the day is, let's say the month is, for example, 1, and the day is any other integer value, we would want to make sure if that is not greater than the maximum number of days in that month, which is stored in this array. So we will compare it with the index position of the days per month array, and if the day is greater than this value, that means that it is an invalid date. Similarly, if the day is greater than this value, then there is a possibility, if the month is 2 and the day is 29, let's say, which means that it is greater than the index position, than the value at index position 2, which is for the month of February, then there is a possibility that this is a leap year, and we want to pass it on from this point. If the day is 29 and the month is 2, then we do not want to validate it over here. We would want to pass it on through to the next if statement. So we will let it go if the day is greater than, or if the day is 29 and the month is 2. That means is although this line is not satisfied, or in this case, since we are doing reverse check, so it means that it is, according to this line, this might be an error or invalid value, but we have created an exception for this value, that if the month is 2 and the day is 29, that would mean that quite possibly that this is a leap year, and we are validating the leap year in our next if statement. So if the day is 0 or less than 0, or if the day is greater than the maximum number of days in that month, then create an error or throw an error. So an error statement can be thrown over here by using the throw statement, throw nib illegal argument exception, that the day is out of range for the specified month and year. Now if the month is 2 and the day is 29, then we'll need to check if that is a leap year. If it is a leap year, that means it is a valid value, and if it is not a leap year, then that would mean that it is not a valid value. And to check that if an year is a leap year, we have a certain conditions that the air need to satisfy, and you can Google those conditions as well. The what are the conditions that an air needs to satisfy for it to qualify to be a leap year, and those are some of those are mentioned here in the if statement. So first we'll need to confirm that the month is 2, that is, if the month is February and the day is 29, that means we are trying to check for the leap year. Then if it is, the air is not completely divisible on 400, this is one condition. And if the air is completely divisible on 4 and it is not completely divisible on 100, then this is the condition that it will need to satisfy for it to be a legal or a valid leap year, and for it to be a valid date for the month of February. So if 29 is the day and the month is February, then we can try and satisfy or check using these conditions that if it is a leap year or not. If it is not a leap year, then we throw an error. If it is a leap year, then we let it go and we assign the values to these instance variables. Now we have the date class over here, and then finally we would want to print these in the form of a string using the toString method. We use the toString method to specify the format for our object or for the output of our object, and now our date will be printed in a single string format, and the format will be, let's say if we have a month, day, year, then we will have, let's say this is the month, this is the date, and this is the year. So we'll have our date in this format. You can change the order since we mostly use the day, month, year format, so we can change the order over here to get more compliant with our own format. These are all integers, so I do not need to change anything else in the format. Now we can create an employee class like the one I had in the previous lecture, and in the employee class I would want to have some instance variables, private string first name, private string last name, and private date, birth date, and private date, hire date. Now what we are doing over here is that, as we can see, we are using the date class that we have created as a data type over here. It is our own date class that we have created. We can call it a user defined data type, and this is the idea of composition, that we can use an object of one class as a variable in another class as its instance variable, and this is the idea of composition. So the employee has a birth date, it shows has a relationship in between the two classes, and as I said that we can have multiple examples of a has a relationship, like the student has a course, a faculty has a course, a car has a steering wheel if you want to create a separate class for the steering wheel, or if you have want to create a separate class for the wheels or the doors, then a car has a brake pedal maybe. So those are the examples of a has a relationship between two classes. So whenever we have a has a relationship in which one class can have another class, then those kinds of relationships are called composition. I will create the constructor for the employee class now, and in the constructor I'll be initializing these instance variable, and for that I'll need to the constructor will need to accept 4 parameters. I said yesterday that we can pass an object as an argument as well. So I'll have 2 arguments or 2 parameters of type date. And now I will simply the start birth date should be equal to birth, the start date should be equal to hire. And what we are saving over here is that we have saved the recoding over here. We are reusing the same code that we have created in the date class. We are using that code instead of recreating the date elements again, the date variables again for these 2 different variables in the employee class. Now we can use the toString method to print these details. The toString method is supposed to return the toString. The toString method is supposed to return a string, and we are trying to provide a certain format to the toString method. You can return any string from this toString method, but I would be returning a formatted string that will print the details of my object in a certain format. So I am using the string.format, or you can simply return anything, any string. It just needs to return a string. So now when you print the object, it will return any string from that employee class. Let me create another file that will have the employee test class. It needs to be a Java file, and here I want to have my main method, and in the main method I can now create an object for the employee class, but the employee class will need to have 2 date class objects as arguments. So it will be asking me to provide the date class objects. You can directly create the date class objects within these parentheses, but over here I will first create the object for the date class first, and that is taking 3 parameters from me. The first one is for the month, second one is for the day, and third one is for the year. And similarly, we have a higher date for the employee, and we need to pass the same variables, the values for the same variables. And now we can pass these two variables to the constructor of the employee class, these two objects to the constructor of the employee class, along with the first name and the last name. Now if we print the details, now if I print this object, what should happen is whatever is I'm returning from the toString method, that will be printed as an output for this object. And that is what the toString does. This object is implicitly calling the toString method of the employee class, and it will return and print whatever I am returning from the toString method. If I look at the toString method again, you can see that I am just returning a random string from the toString method. Whatever I am returning from the toString method, if I print the object of that class, it will return that string and print that as an output for that object. As you can see that it is only returning the string from the toString method and printing that as an output for this object. Since I have not set anything in the toString method, I'll go and change that to something that is more understandable to us. And as we can see that it works the same as emp.toString. It means that it implicitly calls the toString method and prints the returning value of that toString method as the output of this object. Now if there were any other string or if there were any other method in the employee class, I would need to explicitly call that method. But the toString method, we do not need to explicitly call the toString method. It will work the same as by just printing the object of the class, and we'll get the output. Now let's return something meaningful from this toString method, and we'll come back to how it works in a little while. I want to print the first name, the last name, that is the string. Go to the next line, the birth date. Now because of the toString method, the birth date is also the date object is also returned in the form of a string. So I will use the %s for printing the birth date as well. Now let's just first look at the output of the date class. If I print date over here, since I have the toString method in the date class, it should return the date for me in that format. As we can see, we have passed it in these three values, and it is printing the birth date for me in this format that I have specified in the toString method for the date class. Now let's get back to our toString method of the employee class and complete this code. To the next line. And then we'll pass the values that we want to print. So I want to print the first name, the last name, the birth date, and the hire date. Our code is almost complete. We'll just print the employee object over here again, and let's see how our output changes from our previous one. The idea is that it will print anything that is returned by the toString method of the employee class. So let's run this again, and I'm getting now I'm getting the details of the employee in the format that I have specified in my toString method. Now let's try and check if our date class is working fine, if the values or the validation in our date class is working fine. So this is my month, this is my day, and this is my year. Again, this is the month, this is the day, and this is the year. If I increase this to, let's say, 32, and let's see if our code is throwing an exception or throwing an error statement. Let me run this, and if you look at this error statement, the day 32 out of range for the specified month and year, and if you check your date classes code, exactly what is printed in this error line is that you had thrown as exception. So day out of range for the specified month and year. Again, you can throw any statement within these lines or print any statement over here, but it is thrown in the form of an error, exactly the same way as we get from the compiler. And what has happened over here is that the program has been halted, and until we correct this error, we cannot proceed with this invalid value. Similarly, if I have 29 over here for the day, and if I have 2 over here for the month, let's see if 2016 is a leap year. If it is a leap year, it will go through, and if it is not a leap year, it will not go through, it will throw an error. So 2016 is the leap year. That means that it is a valid date and we can go ahead with this code, with this date. If I change the year, now I have the year is 2015, the date is 29 and the month is 2. Let's try and check if it is our code is working for the leap year validation. Now you can see that the day is out of range for the specified month and year. That means that 2015 is not a leap year.